Hello, everyone. Wow, we have more than 250 attendees now here on Zoom and on Facebook. I'm sure a lot more GIS enthusiasts are joining. I hope you're doing well today. For those who just arrived, please feel free to type in your name in the chat box, where you're from, and what company, university, or organization you're representing. Welcome to you all. I hope you're having a great week so far. I am Marife from SuperMap, and I would like to acknowledge our partner for this webinar, the Caraga State University, College of Engineering and Geosciences, and Department of Geodetic Engineering, and the Caraga Center for Geoinformatics. Say hi in our chat box, please, students and faculty of Caraga State U. And to everyone here, it is my pleasure to welcome you to this webinar entitled SuperMap GIS, Geospatial Approach to Urban Planning. To jumpstart our event for today, let us hear some opening remarks from Engineer Miriam Maquinano Santillan, Dean of College of Engineering and Geosciences, Caraga State University.
Hello, good afternoon, everyone. Am I audible?
Hi, good afternoon, ma'am.
Good afternoon, everyone, and good afternoon to all our participants. Good afternoon also to the organizers of this webinar, especially to Ms. Marife and Ms. Erica Jane David and her colleagues from the SuperMap Philippines. And also, good afternoon to our resource speakers, Engineer Ruel Parangat and Engineer Ian Almazan. First and foremost, I would like to thank SuperMap Philippines for the opportunity to co-organize this webinar with Caraga State University, especially with the College of Engineering and Geosciences, Department of Geodetic Engineering, and the Caraga Center for Geoinformatics. This webinar is indeed interesting and relevant as it provides a venue for showcasing the importance and usefulness of Geographic Information System, or GIS, and related geospatial approaches. As some of us may already be aware of, GIS is a widely used technology in building, in business, and in everyday life. It has found vital applications in the fields of surveying and mapping, transportation planning, environmental impact analysis, and disaster management, among others. In fact, in Caraga State University, we have utilized GIS and related technologies in flood hazard assessment, as well as in mapping and monitoring resources. So today, we will learn about GIS in terms of the area of urban planning, with emphasis on smart city development. Through the technical presentations by our highly capable technical speakers, we will look into how a GIS platform like SuperMap GIS can provide a digital system for the construction of the urban digital model. The live demonstration will also provide us the opportunity to witness the technology's capabilities, such as visual display, data management, location service, heat map simulation, exercise application, and spatial analysis, among others. So with this, I am hoping that everyone is excited like me, and I hope you are excited to get to learn new things, as well as appreciate the technologies that will be presented to you this afternoon. Again, thank you everyone, and welcome to the webinar.
Thank you, Dean Santillan, for those inspiring words. We are also delighted to be in partnership with you in spreading the GIS knowledge. So moving on to the topics for today's webinar, we are going to have two presentations. If you have any questions while listening to the speakers, please feel free to type it in the chat box. The technical team will answer the questions in the Q&A session after the presentations. For our first topic, it is on the introduction to SuperMap GIS technology and urban planning solutions. to be presented by Roel Parangat Jr., Technical Engineer of SuperMap Asia and Oceania Center. Roel, the floor is yours.
Hello, good afternoon, everyone. Let me just share my screen. I am disabled to sharing the screen at the moment. Wait. So while we're waiting for the yeah. All right. So can you see my screen? And can you hear me?
Yes, I can see your screen now and you're audible.
Okay, so thank you so much. Again, good afternoon, everyone, and I'm so glad to welcome you here in the 17th session of our SuperMap mini classroom, or what we call the SMC. And this time we'll have it here in the Philippines. I am Roel Parangat Jr., and today I'll be presenting the concepts of SuperMap technology for urban planning solution. So first, let me introduce to you the SuperMap as a company. So to some, maybe our company is new to your ears, but we actually are already existing for 24 years now. It was founded in Beijing, China in 1997 by Dr. Eshun Zong. And since then, we have already served various spatial solutions for different problems that require geospatial analysis. So we are currently 4,000 in our diverse team. So meaning to say that we are composed of different people from different countries, because from being the China's first recognized software, we have expanded to different parts of the world, including Japan, America, and now here in the Philippines. So we have approximately 1,000 partners from 30 plus countries and have 38 branches and subsidiaries. And just a little segue, we are currently looking for new members of our growing team. So if you're looking for a job or an internship or just a GIS partner, you may visit our FB page for more information. It's at SuperMap PH. Okay, so moving forward, if you're new to our presentations, just so you know, we have the SuperMap products is pillared in 5 main key technologies abbreviated in BIT-DC. So the first technology, or the key technology, is that SuperMap is able to run a big data GIS. And when I say big, it does not only mean running huge files, but also having that wide range of analysis. And we all know that GIS is about running data, storing them, presenting them, and analyzing them, and eventually we'll have to present a data in a visual manner. So that's exactly what SuperMap technology can do. And not only that, our SuperMap is also supported AI GIS. So our technology supports the Python environment. So your mapping experience is made easier using the object detection tool in SuperMap software. With AI GIS, we can also predict or estimate a certain value in the future given a parameter, and we can also recreate possible scenarios using the AI GIS function of the SuperMap. And also it's used to making professional thematic maps, and it will actually save time for us if we're working for many data. Third is the three-dimensional function is actually fantastic because you can display architectural design and analyze it using SuperMap technologies. And you can integrate 3D data to other data and present the values. So this is actually the main topic of this afternoon. So you get to know more about this specific key technology. The fourth is distributed GIS. So it means that our product has a different kinds of system where you can run your work from one terminal to another. I'll explain that further later. And for the fifth is that our technology has a cross-platform functions wherein you can run because our products can be run in Windows operating system and Linux language. So furthermore, your GIS desktop experience can also be displayed and analyzed in mobile, tablet, and even in web browser. So yeah. So for the presentation outline for this afternoon, as our host said a while ago, it's divided into two. So this part is about the concepts, and later on you'll see the demonstration by my colleague. So let's go ahead with the first point, the SuperMap 3D GIS technology. So here, I'm sure that the world, that you know that the world is 3D, and there are different features of the earth and assets that you can actually model into 3D, like building, optic cable, even gas and the water system, the sewage system, and all those things. And these assets are these asset classes are typically managed by different departments or company. In, let's say for instance, in the Philippines, right? It's managed by different companies and different um, com- uh, departments. So why 3D? Why not stick with the two-dimensional planning? It's because there are some problems that are real problems that actually arise, such as these things: the multi-roads conflict, the landscape disorders, road profile, land subsidence, urban drainage, and these things are better to be analyzed using this method called the 3D planning. So 3D planning is also considered as much better in representing objects, right? It's more visual because the 2D requires more imaginative. It requires your imagination to study that. But with 3D, it's well represented and given a more real effect and new insight and richer information. That's why we want to translate from 2D to 3D. Okay, so moving forward, this is the GIS product system of the 10i version or 2020 version. So if you can see, there are three circles. The smallest circle is called the cloud, and then the edge, and then the terminal. So let's go one by one to it. The cloud is on the top circle because it's composed of the iServer, iPortal, and iManager. And these cloud-based softwares, it can handle huge amount of data if you're working in a project, let's say, or city project, something like that. So the edge is actually as additional leverage to your iServer performances. So that's in the middle. And last, we have three subgroup of the terminal. We have the web GIS, desktop GIS, mobile GIS. So uh, in desktop GIS, we have a product called the iDesktop. That's the one. That's the most famous one. It's you can run it in your desktop, of course. And we also have the iObjects, and also it can be run in different languages like the Java and C++. And we also have the web GIS that's composed of the SuperMap iClient, JavaScript, Python, and iClient 3D for WebGL and for plugin. And the last, in the right part, we have the mobile GIS because SuperMap offers a terminal in your mobile or in a device that you can handy you can bring by hand. So these are the iMobile of the SuperMap, the iTablet, and the iMobile Lite. So you might want to ask what's the difference between the iTablet and iMobile. The difference is that one, which is the iTablet, you need to have to serve a software development kit so that you can further develop it. Unlike with the iMobile, it's already it's a ready to use thing. So lastly, if you can see this tag, those with asterisks are the ones that then run the 3D analysis. So moving forward, if we are dealing with a city data, it could definitely mean a multiple data sources of 3Ds, such as terrains, pipelines, and other things. So we can actually integrate all the available data to generate a much more visually appealing model or presentation of information and detailed data covered both the above ground and the below ground. So here, the product will be an integrated 3D data. So for the SuperMap 3D history, let's just look very fast to this timeline. We have the 3D sphere actually started in 2007, 2009. Actually, the 3D sphere, if you're using the iDesktop, it's actually the base map for that for all 3D. So it actually started in 2007, and then later on we can integrate 2D with the 3D data that was developed in 2008. And then furthermore, let's go fast forward with this BIM plus GIS in 2015. That's additional evolution to the 3D map of GIS of SuperMap. And then in 2007, we have the new 3D GIS. And fast forward to 2020, we have this server interface standard game engine 3D spatial query. And that's the latest one in the family of 3D product. And hopefully we'll have another webinar for that in the future. But let's only focus on this part. So in this table, we can see that the new 3D GIS applications is divided into 4 parts, beginning with the lowermost rectangle. We have the 2D and 3D integration model containing the several types of data models such as 3D points, 2D network, team, etc. And the second part is a 2D and 3D integration technologies, because we are not only aiming to display the 2D and 3D separately, but we actually want to integrate both data. Also, we are capable to consume different types of data like oblique photogrammetry data, the BIM, the point cloud, and the others. And lastly, of course, we want to import in a software. We can give the output in various formats such as the VR, AR, the WebGL, and the 3D printing. So now let's talk about the BIM plus GIS technology. So you might wonder why is there like such thing as BIM? And we all know that we all hear the word BIM mostly in an architectural field, right? So why integrate it in GIS? Like, why are we explaining this in this webinar if we're only focusing on GIS? So let's know about the BIM first. So what is BIM? Actually, BIM stands for the Building Information Model, and as defined by American National BIM Standards Association, it's a digital expression of construction project, and it's actually a shared resource. And at different stages of the project, different tools insert, extract, update, and modify information in BIM to support and reflect their respective responsibilities in a collaborative work. And BIM has 3 aspects. One is the model data, the standard, and the cycle process. Some BIM design software have created data structures in their software. Let's take an example of BIM design, let's say Autodesk. The data and the file created by Autodesk may not work with the other BIM application. So that to achieve the interoperability between the application, open standards for sharing BIM data among different software applications have been developed so that BIM can be used for the entire cycle of structure from planning, design, construction until the maintenance stage. So in order for this application to be standardized, we need the government to give a standard for that and some rules to it. The BIM Alliance would also be a part of it, and the association, so that we can integrate, we can use BIM in all the cycle plan of a structure. And if in that case, we can analyze, or we can see that the BIM application has also a delimitation. So one is the lack of macro level, because we know that BIM focuses on the management of the whole life cycle of buildings but lacks in the surrounding macro geographical environment. So meaning the BIM is only limited to the structure itself, but it does not go with the analysis beyond the building. So beyond the walls of the building, there's no data to it. So that's one of the delimitation of the BIM application. Second is data inconsistency. Just might there are many kinds of BIM modeling software and data format that might be inconsistent. So as I said a while ago, one BIM application might not run might not run in the other application. And the last the limitation that we can see is that the lack of maintenance of management. So it's focused on the design, the construction. It's also doing great in that, but it lacks in the late operation and the maintenance management. So why am I explaining this delimitation? It's because with the use of GIS, we can actually make a solution to it. So first is the cross-border integration of BIM and GIS. BIM is used to integrate and manage the information of the structure, while GIS, as we all know, is used to integrate and manage the information of its external environment. So BIM plus GIS have a natural complementary relationship, specifically the 3D GIS, because BIM data is an important data source of the 3D GIS. Without BIM data, there's no 3D GIS. So, which can make 3D GIS move from macro level to the micro, and it can run management at the same time. On the other hand, the integration of BIM data makes the 3D GIS move from outdoor to indoor. So it's a two-way thing. Okay, so from GIS benefiting from BIM and BIM benefiting to GIS as well. And BIM from this one, I will just explain further that BIM from micro to macro level using GIS. So as we can see, since the BIM is targeted at the fine model of the BIM monomer, it cannot be separated from the surrounding micro geographical environment elements. And as we all know, GIS has been committed to the research of macro geographical environment, providing a variety of practical query and analysis functions while providing location services and spatial analysis. So let's take a look at these two photos. So the one in left, okay, let me just hide this. The one in left, it's a BIM data. And we can see it's a good BIM data of a bridge. So you can actually rotate it and look at it in different aspects or the different dimensions of it, but what it lacks is the black part. So what's outside that, right? Where does this structure is built upon? And then comes the GIS, wherein now we can see that by integrating the BIM to GIS, we can see the external factors of this bridge. And now we can see that, this black areas actually has trees and residential areas. So what now, right? Well, it can add to the planning aspect of the BIM so that you can actually plan which areas to go to. Which areas to perfectly build that structure, and what other external factors can help. So this one is a BIM model expression and capabilities. I'll just read it one by one. Spatial calculation. BIM model can also run spatial relations and reduce the dimensions and spatial analysis, volume calculation, and also the 3D printing. So you might ask, how do you import the BIM data into GIS platform? So as we all know that the BIM data, it's actually huge, are actually huge in file. So how do we import that? So importing BIM data into GIS platform it's not a major problem. One of the GIS innovation is being able to read BIM data natively. So no further conversion is needed. The vertex and attribute information can be exported at once and can be exported by category. So native read meaning that the BIM, whatever the BIM format has, it can be run in the GIS software. But sometimes there are BIM model representation. This one will show the BIM model representation of the GIS platform. Um, some GIS platforms needs a plugins that are needed to break through the bottleneck of the BIM data access to GIS software platforms. And with that, GIS software has developed data export plugins for BIM software such as Bentley, Tekla, and Autodesk Civil 3D. And meanwhile, it supports the import of the interchange formats such as IFC, the CTGML, and the other formats. Some GIS software also has a deep strategic cooperation with BIM-related companies. So now it supports a direct opening of some related BIM data in the form of data sources. So therefore, through this, the close connection between BIM and GIS data is now achieved. So these are some examples of the BIM data that can be displayed in the GIS platform. We have the CATIA, the Revit file, the SketchUp, and the IFC. So how do, you might ask, how does the GIS platform carry massive BIM data? So let me explain. So processing massive BIM data, the GIS platform can use the LOD, level of detail technology provided by the platform. It is it's to determine the resource allocation of objects, rendering according to the position and importance of the nodes of the object model in the display environment, and reduce the details of non-important objects so as to achieve the efficient rendering operation. And when the 3D scene is zoomed in, the model presents a very fine performance, but when the whole scene is viewed, the model is displayed in a rough way, which maximizes the occupation of resources and improves the performance of the whole 3D scene. And the second one, the one below, there are a large of number of, let's say, a BIM object, let's say a door, in a house, and the instantation rendering technology is used to save and draw only one subject. And the effect of it is that it reduces the pressure to the GPU and RAM, and it improves the performance of 3D scene. On the other hand, the GIS platform also provides a variety of BIM lightweight and triangulation network operation, including extracting shell and internal separation, triangulation network simplification, sub-object simplification, deleting repeated vertex, and computing normal modeling splitting, and others. So these two are some examples of projects that are implementing BIM lightweight operation. So let's go ahead to the BIM plus GIS operations in SuperMap. So first example is a browsing experience. So even in a huge amount of BIM files to form a huge city model like this, we can see that the data hugeness isn't much of an issue in browsing experience in SuperMap GIS platform. So you can also rotate the model depending on the angle of your choice. So yeah, that's an example to that. Second thing that we can do with the 3D Spatial is with the 3D model, the 3D BIM model is the 3D spatial and attribute query. So on this video, it's showing the overlaid BIM models and base map. The BIM model can be queried by the attribute. For example, let's say this one, I want to look at the objects that are in the first floor. So you can actually run query using, of course, the GIS platform, which is the SuperMap, in order for us to remove all the other floors or all the other objects in the floor, as you can see in that illustration there. See, the first floor only. So also an example, let's say you want to show only the windows in the eighth floor. You can, instead of like counting it individually, the result of querying is actually in the attribute table. So you'll have the list of all the windows in the eighth floor or whatever floor you define. So yeah. We also have the section cutting view. We can also display the BIM model using the cut sectioning view. It is, in this figure, we can draw a box that can cut sectioning to see the models inside the box only. So let's say this huge office or building, we can cut it to your concern space only. For instance, this is your office and you just want to look at it and never mind the other all these rooms, then that can be done in SuperMap GIS platform. Then next is we can see the BIM construction scheduling model. So in practical application, this process of building construction can be simulated, and the building production can be viewed based on the construction progress and time. So in architectural field, this can be used to view progress in the proposed Gantt chart. So yeah, the architects are, if you're working on a project like this and you want to see, let's say, how is my building would look like in the 40th week of um, of construction. So you have this here in the left side, you'll see the dates, and then it's like a motion presentation of that. So that's another thing that you can do in the GIS platform. And these are the other things that with the continuous accumulation of large-scale 3D data, the integration and matching of multi-source data becomes particularly important. And in this figure, it shows the BIM can be integrated in scene, in a water surface like that, and the oblique photogrammetry you can see here, and the BIM and a video. So you can see here it's a city, and then there's like a little window for let's say a CCTV. So now you can have the video integrated with the BIM using the GIS platform. So now let's go to another word. Now that we call it the city information model. So, but before that, let's say I have this city, and I have clouds of questions with it. So let's just take 1 to 2 questions. Let's say I want to, there's a pop-up idea, and you're actually, let's say for instance you're working in a urban place, and then you just suddenly have this pop-up idea like, I want to place the BIM models in an actual geographical location. Or someone asks, I want to manage underground assets in my city. And let's say I want to query and analyze the building for asset management, and so on and so forth. And you can actually notice that these questions actually arrive from different urban planners or departments. So one is probably working in the underground level, and the other one is just practicing the BIM, or some other are working in the pipelines and the building itself, and etc. etc. So these kind of questions can actually be answered by using the integration between the BIM and the GIS. And because BIM plus GIS can actually play a greater role in the city level. So now that you know about the BIM and the GIS, I will introduce another term to you, which is the city information model. Let's say the buildings are the cell of the city, and or the other things in the city, those are the cell of the city. So BIM plus GIS can manage those cells, as well as the environment around the cells and the various connection networks. That is actually what makes the city information model. So city information modeling is an organic synthesis of 3D urban spatial model, and urban dynamic information, forming a comprehensive urban information management platform, including BIM geospatial data and Internet of Things, or the IoT data, and it is the future of development trends of the BIM plus GIS. With CIM, we shall promote smarter cities to a higher level. So here, let's take a look at this figure. The successful implementation of a city project requires the development of digital system that can manage and visualize the geospatial data in a user-friendly environment. Of course, we want that. And the GIS offers advanced and user-friendly capabilities for smart city projects. That's why GIS is everywhere in the city. Just don't know probably, or probably you're already exposed to GIS. And there are a lot of platforms used to development of the city. GIS platform is one of them, of course, and the GIS platform could help to enhance understanding the city condition through location information. So what can GIS do in representing the city condition in the smart city operation? So GIS can actually perform visual displays, location surveys, heat map, simulation exercise application, special analysis services, and planning models into the entity space. And those functionalities can be featured in the smart city application. For example, at the business application, we can use that in the traffic application as well, the urban management application, emergency application, water application, and the social governance, and so on. There are a lot more integration of two maps in order to have this city intelligent model. Because we know that we all know that the GIS maps represent a form of information as an answer to a specific question in a certain field. So, for instance, you are working on the land supply that can support industrial planning. So we have the industrial layout, and then we have the educational resources, and so on. So meanwhile, the analyzing and the analyzing the condition of an area often requires different GIS maps to get more accurate information. So then what do we do if we have a lot of kinds of GIS maps that we need? If the desired information is complex, then we can still merge various types of maps and analyze them together. And so that's how City Intelligent Model adopts the GIS technology. Can you guys still follow with all these concepts and the figures? Well, anyway, moving forward, the GIS needs further strengthen openness. So there's a strengthened openness of information, because the strengthened openness of information provided in the city application can be further enhanced with the implementation of GIS technology. And why do we say that? Because the latest GIS trend has been improved significantly. For example, in the field of visualization and experience enhancement, GIS can display the data in an interactive way through its map visualization effect, statistics, chart, report, and others. And as you can see in this first figure, we can see that this city map, there are like datas at the side, like the graphs, probably let's say a population growth, we can see this, and other things. Yeah, so we can actually have it more interactive way so that the users can actually browse it wherever they are. And besides, the concept of smart city will be more interesting if the system itself could integrate a lot of data and technologies in the IT trends. So that's another point. So, but actually that's more of the GIS evolution, or GIS additional trends. So the GIS technology has now achieved these conditions, and also like the one I have discussed earlier, the combination of GIS and BIM provides a powerful tool for the construction of urban digital model with georeference data and visualization of the data in a user-friendly environment, of course. Okay, so let's take a look at this architecture to know about the future city. The implementation of city project is based on number of steps, including the construction of the urban digital model, data collection, data analysis, interactive data visualization, and so on. On the data collection part, there are many data which can be accessed and import into the system, such as the IoT streaming data access, industry database access, VM structured data aggregation, and video data aggregation. Integration of many data would mean the system contains rich data display. Of course, with a lot more data, there's a lot more to display. Data could also be enhanced by images, videos, audio files, resulting in a construction of urban big data. And another step is in implementing a city project concerns the development of analytic environment which convert real-time and historic data into operational data that improves the security, efficiency, and quality of urban systems. And the last step is developing an interactive display that allows the user to interact with the city's components and stakeholders in a user-friendly environment. Yes, I keep on saying the user-friendly environment because we want that, right? We don't want this that's too technical to view. And with the world right now, it's everything is like smart, right? Smart phones, you have the smartphone, so you can actually just access what the city plan in this city in your mobile phone. So that's another improvement to the city management. And I know that this table might be highly technical, but the only point here is that in CIM, we don't just integrate between the BIM data, but more sorry. Okay, so moving forward, let's say let's see this what do you call this the idea of this is that the new the build it builds the city neural network. So yeah, it's like a integration of too many data. So let's move forward. The BIM plus GIS technology in CIM. So where do we actually use the BIM plus GIS? We have 4 stages of the construction. We have the planning stage, the design stage, the construction stage, and the maintenance stage. So I'll just go to it very fast. So one example is the planning stage. We have the site analysis, structural programming, and the project demonstration. So here we have the design stage of the BIM of a structure. So that's another application of the BIM plus GIS technology. And then we have the construction stage. These are the example of the successful projects that we had before in the construction stage. It's a large scale construction management project with video monitoring like that. And the maintenance stage, these are also the example of that. And yeah, let's move to the 3D GIS urban planning. Now that we already know the BIM plus GIS technology as well as the CIM, now let's talk about the application of 3D in the urban planning. So these are the examples of the 3D GIS for urban planning. So that's the display of the true world in a better diagram, and it solves the real problem. And we have the display indoor and the underground space and automatical management. So these are the components of the 3D planning. Of course, we have the 3D planning itself, and then below that, there are the special planning, the urban design, and the regulatory detailed planning, which I'll be explaining in the next slides. So yeah, so what can 3D GIS do for the urban planning? Of course, with the 3D GIS in urban planning, we can have a 3D view, of course, and we can also run computations in 3D in a 3D manner, and I don't know the 3D computations of data, and we can also analyze the data of the 3D and some complicated computation. And below that, there is like a a system to that. Of course, the planning, approval, use control, and the supervision. So as a GS software, the position aspects will certainly be the most concerned. So we do not only try to display the data, but also we want to make sure that the data is in right position and size, specifically after the data is successfully displayed. And we will get more benefits further by analyzing it. So we have the 3D spatial expression, and then we also have the functioning operation, and then we can export the 3D as well. And further, the SuperMap is actually focuses on this. That's why we have the AI technology as well, because we can customize development such as the WebGL. And later we'll have the demonstration for that part. So moving forward, the planning application system, we have here the above ground space verification, regularization range box, above above and underground building range. So yeah, you can see that. And then the above ground and underground elevation. Now let's proceed to the urban design. So with the urban design, in the previous case, the planning was always done in the 2D. We all know that. And by using 3D technology, we can give more logical and specific scientific reasons for the rules in the urban planning. And that way, it is hoped that the relevant parties will comply with these regulations, and we can obtain a decent urban quality. And these are some requirements for the GIS, the requirements that has of the GIS capabilities for urban design. So to build models rapidly based on the building base, of course we want that, and we want actually to run spatial operations in the GIS platform for our urban design. And the result of the analysis should not only be seen but also be used, of course. Yes, and not only good to use but also beautiful in display. And lastly, we want to not only to be displayed in the desktop. So just one example how to build just one strength of the GIS platform that is required in urban design. Let's take a look at this video. Yeah, you can see this particular building and this small box. You can define actually what floor or what height of the building you want to input. So I can't see the figures, but actually we know that the figure of this building is much higher than this one, and probably this is a mall or something like that. So yeah, you can define and easily just input the value, and then the building will go up depending on the values that you have inputted. So the urban designs applying, of course, in urban planning there are certain rules that you need to that has to be implemented, and I'll just go further with this. So with this, with the rules that is already implemented in the city, we can use the GIS in order for us to know which areas have already violated. How? The 3D real space in the left side can be translated to the digital space, and then with following this chart, we can conciliate with the spatial conflict with the 3D real space using the digital space. So these are, in the following slide, I'll be showing some applications of 3D GIS, and everything is in automatic examination. So let's just move forward to this. This one, it's only just says that the rules, with the rules, we can apply it to solve these problems that are actually occurring in the city. So the rule base, we can use the 3D, the SuperMap 3D designer in order for us to have a intelligent management. So the strengths of the SuperMap 3D designer is that the powerful multi-source 3D heterogeneous data integration capability. It's also rich data operation and analysis functions, flexible rule customization capability, beautiful scene display, and service providing capacity. So this is one example of rule construction wherein, let's say for instance, in a city, there's a rule for us to keep a safe zone for pedestrian crossing, and we want to remotely manage the city. We want that, of course, and by using the GIS technology, we can identify which buildings has violated that rule. So by drawing this red line, okay, the red line in here is, let's just define it as the safe path for the safe path for pedestrian, and then running a special 3D spatial query in SuperMap, we can analyze which building in the street violated that rule. So this one, you can see in red, has already expanded too much of the rule and was already, yes, moving forward. Additional application is a while ago it's about the above ground. So this one, of course, there are also problems beneath the ground like pipelining, like that. So we also want to see which areas or which pipes has already violated some regulations of the city. And this one is about the height naman. So a while ago it's the horizontal and now it's the vertical regulation. So we can see that this building has already exceeded the city rules of building a structure up to this point on. So you can see here. Yes, moving forward, the sunshine duration in every house unit. So it's about the sunshine or the sun rays of how much sun in a day would pass through your, let's say for instance, this condominium. If you're living there and you want to know how much sunlight is passing through your unit, given the elevation and the obstruction. A while ago you can see some buildings here, so we can see that these areas has a lot more sunlight than the others, and there's like a pie chart here, so you can know how much sunlight can is there in a day. So yeah, moving forward, openness analysis is just from this point of view, which areas are visible and not visible. So the green, of course, is visible and the red are invisible. And later we'll have a demonstration for that. So I'll just move forward. Also the viewshed analysis. And the skyline analysis about the drawing a skyline outline and also the sense of spatial hierarchy. So some successful stories, I'll just move forward to this. We had a successful case of the Shanghai Center. The Shanghai Center is a huge building, and tower in China, and the total BIM data size is 252 gigabytes, and the number of 3D models are in 3 million. So that's those things. Let's just watch this very quickly before we proceed to the next part of this webinar. Yeah, as you can see, some pipelines of it. You can see that. Also, planning of evacuation if there's a fire, and so on. That's application of the BIM plus GIS. So this one is the urban planning side. So using the planning department of Hong Kong, online planning and design system, we have the urban planning skyline analysis, the one I showed a while ago, and the planning scheme reviewing the red light and the 3D scene, the real 3D scene, that part. So those things that you can apply using the SuperMap. And lastly, wait, do we still have more time? Okay, I'll just show this very quickly. Oh, sorry, I don't know if you can hear the sound, but it's actually loud. Sorry if you're using earphones for that. Anyway, yeah, this is um, a video of geodesign platform for town planning in Hong Kong. Let's move forward. See this analysis like view shed analysis and those things. Basically, you can do a lot more things to in SuperMap. And later, again, we'll have to go to the most exciting part, the demonstration. So yeah, I think this is an example of also a city smart project or the CIM, where in a particular city, some information can be viewed in graphs at the side. And if you notice, it's in Chinese characters, but actually, once you have it in your desktop, there are actually other languages available. Of course, in English, it's available. So yeah, that's it for my presentation. And if you have questions, please chat it in the chat box, and we'll be answering it in there. So for now, let me give the virtual floor to our host, and thank you so much for actively listening.
Thank you, Ruel. Pretty cool, right? That was just a sneak peek of the applications that can be done with the SuperMap GIS technology for urban planning. While you're letting all of that sink in, maybe you can also start wondering on how you can utilize this kind of technology in your field or industry. We're excited to hear about what you come up with, and we're very open to collaborating with you to make that happen. Again, if you have any questions about what Roel has just presented, anything about the BitDisi technology of SuperMap or about urban planning solutions, please head to the Q&A chat box below and our technical team will answer them. At this point, let us have a quick 2-minute break. Meanwhile, kindly fill up the form for evaluation and attendance found in the chat box below. The form will be open until the end of this webinar. See you again in a bit. And we're back. For our second and last topic, Ian Almazan, also a technical engineer of SuperMap Asia and Oceania Center, will be presenting to us a demonstration of geospatial approach to urban planning using SuperMap technologies. Ian, the virtual floor is yours.
Good afternoon, everyone. So welcome to the demo part of this SuperMap mini classroom. So let us start with a short PowerPoint presentation for an overview of what we will be covering in this demo. Okay, so the live demo is about making an online dashboard containing a 3D scene. So we will cover 4 main parts in our demonstration. So first, we will prepare our 3D scene in SuperMap iDesktop, which is our desktop application, and then publish our prepared 3D scene in iServer, register the 3D scene in iPortal, and finally, create the online dashboard so we can display our 3D scene and explore our data in our browser. Okay, so there is actually a 0 step, which is configuring iServer, iPortal, and iServer data store, as well as starting them. So these are the server and portal applications of SuperMap for displaying things on the web and acting as your server for the data you want to display. And next is, of course, the data preparation in iDesktop. Again, our desktop application. Then this is 3D scene preparation in iDesktop. So this is a snapshot of our data that we'll be using today on the upper right-hand side. And next, we will publish the 3D scene in iServer. So it will become a web service that can be used by our portal. So once we have the service ready, we will register it in iPortal so we can add it to our dashboard. So the one on the right is actually the dashboard that we are aiming to make in this demo. Okay, so the first part that we will do is actually start our iServer, iPortal, and iServer data store. And to do so, we go to the root directory and run startup that batch for each one. So that one is for iPortal. This is for iServer data store. And lastly, for iServer. So we're just doing this now, so we don't have to sit and wait later as they initialize. Okay, so the three software are now initializing. And let us now move on to this beautiful 3D scene of a city in China. So this is actually sample data that will come with a download of SuperMap iDesktop. So as you can see or remember from Ruel's presentation, we said that we use BIM models in 3D GIS. And here you can see the BIM model. So the buildings are beautifully rendered in 3D, as well as you can notice the water bodies with the rendering of the reflections of each building. So this is not just a beautiful 3D display. We can also do some GIS analysis, of course, since this is GIS. Okay, so let's demonstrate some GIS functionalities in this 3D scene. So let's make this part the subject of our analysis. Okay. And the first analysis I would like to show you is this one, the shadow analyst of iDesktop. Okay, so let's run for this group of buildings right here. So I'm just selecting the area for the analysis. And right click to end after drawing the polygon. And then wait for the result. So you can see that we produced a 3D array of points that are color coded according to the amount of sunlight that it will receive in a 6-hour period. Okay, so based on the settings of the tool, the color ramp we're using is from blue to red. So the blue points receive the least sunlight and the red points receive the most sunlight. And we are analyzing at a height of 20 meters or up to a height of 20 meters above the ground, as well as using a time period from 6 in the morning to 6 in the evening. So this is a 12-hour period. So you can see here the advantages of 3D GIS because unlike usual 2D grids, our result here is also varying in the z-axis or in elevation. So you can see that behind the building, we have blue points on the ground which receive minimal sunlight. But as we go above the roof, as we go above the roof of the buildings, it becomes yellow to red. So we can see the variation when it comes to elevation, not just the horizontal plane. And you can see that here, where there are no obstructions, it's it's almost all red and orange. Okay, so I think that showcases the shadow analyst tool. Another tool that's very useful in 3D GIS is our view shed. So let's go for the basic view shed analysis in SuperMap. So with this, we will select a vantage point or point of perspective, and then select a direction which our imaginary person will look to. So here, the green parts are the visible parts from our point of view or our point of perspective. And of course, we can change it. So this XYZ is the coordinates of our point of perspective. And then this view shed is for a point of perspective 1.8 meters above this position. So you can see if we increase this to 5 meters, the point here rises up, and the visible and invisible areas are also updating. So again, let's change it to 20. There. Now you can see the roof. You're taller than the building. So, okay. I think that's enough with this beautiful sample data. Let's proceed to a blank iDesktop window here and start loading the data I actually prepared for this demo. So let's open our file data source. So this is the file data source. It is in UDBX format. So most of the data that you will work with, or almost all the time in iDesktop, you will be using the UDBX format. It is the spatial database format of SuperMap. And here you can see the data that we have inside it. So let's just remove this one for now. Okay, so we have a building data set. So this is in Dumaguete City. And we also have roads. So this data is from OpenStreetMap, our favorite source of free data. And let's take a quick look at the attributes of our buildings. So we have the usual OSM attributes: ID, OSM ID, building type, building name, amenity. But at the same time, we added a height attribute for the height of the building. So this is just dummy heights. We don't actually have building heights in Dumaguete. And we also have SRTM min. So this is elevation for the base of the buildings derived from the SRTM digital elevation model, as well as barangay names for the barangay where the building is located. Okay, so and if you're curious, in UDBX you can actually import all sorts of data set into your spatial database. So you can add shape files here, you can add KML files, well-known text files, and all sorts of spatial data, as well as table data. Okay, so let's close our map and actually proceed with the 3D scene or production of the 3D scene in iDesktop. So let's start with our building. So we will right click and add to new spherical scene. So right click and zoom to layer. Okay, so these are the buildings in our data set. As you can see, it is on a spherical surface, since this is a spherical scene. And then let's proceed in adding the satellite image. So this is just a Google satellite image, okay, for the area. As you can see, it's flat for now, but once we add the SRTM DEM, so we will add it as a terrain layer. So for digital elevation models, you can either add as terrain or image. An image will just add visual value. So let's add them both for this demo, or let's add it as both. So as you can see, since we already have a terrain layer here, we now have 3D ground. You can now see the mountains of Negros Occidental. And this is the image layer. So we don't actually have any use for this in this demo. Let's see. So here, now we have a 3D ground. And for our buildings, we will extrude them using the height values that is in its attribute table. So to do so, we will go to the style settings. So right now, the altitude mode is clamped to ground. Let's change it to absolute. Set the altitude of the bottom of the buildings to the SRTM min attribute to get its value from the SRTM digital elevation model, and then set the height of the building, of course, with the height attribute. Okay, so now you can see that we have extruded the buildings, and this is more, this is closer to the reality of the terrain in the area. Okay, and just as we did with the CBD 3D scene or the sample data, let's demonstrate some analysis. So in the last part, I showed you the view shed. So this time, maybe let's go with its little more sophisticated counterpart, the dynamic view shed analysis. So just like in the view shed, let's select a vantage point, but this time we'll select a start and end point. Okay. And then our view shed actually travels, and you can see the visible and invisible areas as it traverses the ground. Let's see the tool, and you can actually see that this is actually, sorry for the this is actually a person walking. So we can actually change this to a car, or a female person, or a plane. So that's the airplane for the dynamic view shed. So let's just go for a car of the view shed or test different parameters. So again, this is the dynamic view shed analysis. Okay. And another 3D GIS tool that I would like to show you is the profile tool. So this is very, very useful for anyone in the surveying or mapping industry. So here, profile analysis. So let's test it here in the mountainous area. So let's make a profile section just like that. And as you can see, it generates the longitudinal profile of the terrain. And then I also want to demonstrate the profile tool where a building is involved. Let's try these three buildings right here. These ones, I'm talking about these ones. So again, profile analysis. And there you can see the three buildings. It's in the profile tool takes into account our extruded building dataset. And lastly, just like any GIS or any good GIS application, of course, you can also do queries in SuperMap. So let's just change the symbology of our building layer. So just change the color to some shade of red to make the selection much easier to see. So say we want to query which buildings have heights below 15 meters. So to do that, we go to the Spatial Analysis tab and make an SQL query. So we are interested in the building data set. Let's select everything and set our query parameter to building heights less than 15 meters. So let's go for 20 meters. So we can select one. And then our results, let's select highlight in scene and go for query. Okay, so as you can see, those highlighted buildings are buildings with heights below 20 meters. And you can verify that visually, since you can see the non-highlighted buildings are taller than the highlighted buildings. So that verifies that the query is actually correct. Okay, and let's now save this 3D scene. Close and save this 3D scene. Okay, and let's start with the actual 3D scene that we will be publishing in our online dashboard. So since it's a 3D representation on a sphere, on a dashboard, you can only show data sets in two coordinate systems. It's either the Web Mercator or the WGS84 projection. One of the most popular projections, EPSG 4326. So if you will check our data sets, here are the attributes or the properties. We are actually in WGS 1984 UTM Zone 51 North, the UTM zone for the Philippines, and of course also for Dumaguete City. So let's reproject our data. So this is how you reproject in iDesktop, and select our target projection. As I've said, we will select WGS 1984 and name our resulting dataset. Okay. So this is now the resulting the building dataset, and it's in DCS WGS 1984. So again, we are going to add this to a 3D scene. Okay, zoom. And then, just like we did earlier, we are going to extrude the buildings using the building height. But this time, we'll use just 0 for the altitude. So we're not using a terrain layer, and extruding once again with height. And we're also going to show a classic GIS function. So we're creating a thematic map for our buildings. And we are basing our thematic maps on the barangay attribute. Okay, and selecting a cute color ramp for the map. So I might like this one. This one. So okay. So I kind of like this color ramp. So you can see it sort of delineates the barangay boundaries in Dumaguete. So so these are the barangays and the corresponding color for each one of them. Okay. So let's save this 3D scene. Okay, so in order to publish this in an online dashboard, we need to create a scene cache. So the scene cache is actually the data that we will upload to our server to become the service that we'll be using for our dashboard. So compression type, txt, STME. So there are the different compression types for a cache for different terminals. For our purposes, TXT is the proper one. Then let's select our working folder. So this is correct, and then generate. And then let's save our workspace before closing it. Just close it for now. Okay, so this is the scene cache that we made, and there is also a created workspace. So let's quickly check if we published the correct cache. Okay, and while iDesktop is loading, let's start our servers. So for iServer, the address is localhost 8090. For data store, it is localhost 8020. And for portal, it is localhost 8190. So these are now accessible since we initialized our applications earlier. And then now back to the iDesktop. So as you can see, this is the workspace in the cache file, and the only thing in here is a 3D scene, and this is the 3D scene that we want the cache of. So this is correct. Okay, so let's close it. Then actually start with the server. So this is iServer. This is data store. It just says that my relational database is already configured. And this is iPortal. So if it's your first time using these softwares, you will need to make an admin account and connect your server to your portal, as well as connect your data store to your server. So as you can see, I've already set mine up. So I already have my server registered in my portal, and it is also registered as my hosting server. Okay, so moving on to actually publishing the server 3D service. So let's go to manager and quickly publish services. So yes, we want to publish a workspace file, and let's remote browse to our file. So this is our working folder. This is the folder of the cache, and this is the workspace that we want. And the kind of service that we want is a REST TD service. And next, finish. So this is now the TD service that we just published. And now this is the URL of our 3D service. So then let's open this link. And scenes. So this, we can see a preview of the cache or the 3D service using WebGL. So this is our data set, and we are now viewing it in our browser since it's already a service. Okay. And next, we'll be adding our published service as a resource in our portal. So let's go to the resource center and select what kind of resource we are adding. So we're adding a scene, add scene, and we are pasting the service address. So with this one, you actually need your IP address. So you can't use just localhost. So let's get our IP address. So here, place localhost, and okay. Okay, so we've already added our TBC. And next, let's add more data. So I've prepared some tabular, some Excel files containing tabular data related to urban planning in our city, Dumaguete City. So we will upload them. So as I've said, they are Excel files. And let's select our files. So we have Dumaguete Barangay data. So we don't have any geographic data in our Excel files, so we're unchecking them, or unchecking those boxes. And we'll do the same. So we have 4 Excel files. So, and this is the one we just added. So we're adding 3 more. So we have disasters. Excel. We also have land use. And lastly, we have population and land cover data. Oh, sorry, it's supposed to be Excel. Okay, so let's recheck our uploaded data. So it's in my data. So we, as I said, we have 4 Excel files and 1 TBC. So we are now ready to produce, or produce our dashboard. So in the iPortal landing page, go to Map Dashboard. And then for us, we will select the blank template. So going back to the PowerPoint presentation, so this is the target dashboard that we'll be making. And let's begin. So in the dashboard composer, you go here to add objects. So of course, since this is a SuperMap presentation, the first thing we will add is the SuperMap logo. So custom and add an image. So this is the SuperMap logo. Let's put it somewhere here. Okay, and then let's add text for the title. Monitoring system. Let's set the alignment to left. And let's also add the date and time. Smaller. Let's make this. Okay, and then let's add our 3D scene. So go to the scene and then drag. So let's just resize the bit first. And then select which scene we want. So my scenes, this is Dumaguete buildings. And it will now render here in this window. And let's select a nice viewpoint for our data. There, I think that's good enough. And then let's add some meteorological data about Dumaguete. So let's search for now. City temperature. So it's 31 degrees Celsius in Dumaguete. So let's add that using an indicator. So unit is Celsius. The temperature is 31. Let's change the color to something more appropriate for temperature. So something hot. So orange. And then let's add a background to our indicator. Oops, not this one. This one. And let's replace the title to temperature. Okay, and I'm just going to use Control C and Control V to replicate this object to add data about the wind and the precipitation. So there's 11 kilometers per hour wind speed. So let's add that. And change the color to green. And then for precipitation, it's 24% chance. So for the units and then for the data. So since it's precipitation, something blue, then let's just make this a bit bigger. Okay. And then next, we will start adding our graphs. So let's start with the line chart. So with this one, we want to represent the change in land cover over the years. So let's select the land cover. And then select the data that we want representing our graph. So these are the land cover data sets. Oops, water others. Okay, and let's set the unit. So this is actually area in hectares over the years. And then select the color ramp for our data. Okay. Next, the histogram chart for the buildings. So let's select the barangay data. Okay, so here we want to represent high-rise and non-high-rise buildings in the area. On the x-axis, we want barangay name, but since there are a lot of barangays, let's tilt the labels by 45 degrees to accommodate all the barangays. then let's reduce the padding on the right. I think 5 is enough. And the labels, we can select right alignment to make them better position. Okay, and then just select a color ramp for our data. Okay. And then now let's add a pair of pie charts. So what we want to represent in the pie chart is the division of land uses in the city. So I will take this chance again to remind you that this is dummy data, so this is not actual data of Dumaguete. So let's select a color ramp that's appropriate for land use. Okay. I like this color scheme. So we're adding 2 pie charts, so we actually don't have space for the labels. And lastly, another pie chart. This time for the disasters that the Dumaguete experienced in recent times. So what we want to represent is okay, damages, the amount of damage caused by each kind of disaster. So we're selecting a more apt color ramp for disaster. This one, and then let's just copy the dimensions of this object, so 232 and 208, just to make sure they are of the same size. Okay. And then lastly, we will just add the labels. So let's copy the text. We want it, of course, smaller than the title, maybe 15 pixels. This is high-rise and high-rise buildings. And let's just copy and paste it to label the other charts. This is cover area. And use area. Change the dimensions of our label. And this is damage by disasters. Okay. Then, so I think that's it for our dashboard. Oh, sorry, we can add some more flair to our dashboard. So let's turn on scan and select search. Sorry, there is an error with my dashboard. Let's just add it again. Okay. Okay, I don't think we'll be adding the scan for the demo today. So okay, so we're finished with the dashboard and we can now save it. So save it to get the city monitoring system. So once you've saved your dashboard, let's go to the portal landing space or landing page. So our dashboard now appears as a resource. So here, this is our dashboard. So we've already saved it. And then we can now publish the dashboard. Okay. So this is now our dashboard viewed as a web page. So you can see it has retained all its hover effects, the maneuverability of our 3D scene. You can still zoom and pan it. And you can also view the data here, the data from our charts. So we've accomplished the goals of the demo. And I think that's all. Oh, sorry, there is one more part. The last part is teaching you or showing you how to turn off the iServer and iPortal. So to start it off, we use the startup.bat, and to shut it down, of course, we'll use its counterpart, shutdown.bat. So I will just do it for the three software. And as you can see, the loading screens or the windows for those pages now closed by themselves. And I think that's it for the demo. Thank you very much for attending.
Wow, that's just incredible. You know, before when I was also just once an attendee of SuperMap webinar and not yet affiliated with this company, I get really excited and amazed with the functionalities of the software. So thank you very much, Ian, for sharing with us the demonstration of SuperMap's GIS technology that can be used in urban planning. And there we have it. Our speakers just gave us a comprehensive presentation of SuperMap GIS, Geospatial approach to urban planning. We hope that by this time, it is bringing you some new ideas on your current projects, researches, or businesses. While the presentations were ongoing, our technical team has actually answered your questions already in the Q&A chat box. So, but if in case you would like to ask more, feel free to send us a message. We hope that this webinar has sparked your curiosity about SuperMap, because we are happy to announce that we will be offering a free trial license to our participants here. Certificate of attendance will also be given after submission of output using any of the SuperMap technologies like iDesktop, iDesktopX, or iPortal. Just send us a message or an email as you can see on this slide. To cap off our event for today, let us hear some closing remarks from Engineer Jojin R. Santillan, Director of Caragas Center for Geoinformatics and Chairperson of Department of Geodetic Engineering, College of Engineering and Geosciences, Caragas State University.
Good afternoon, everyone. On behalf of the organizers of this webinar, I would like to express our gratitude to our speakers and participants who have virtually come together for us to conduct this informative, interesting, and successful webinar. Also, I would like to personally thank SuperMap Philippines for the opportunity to co-organize this webinar. I think in the past 1.5 or more hours, our speakers, Sir Well and Sir Ian, showcased SuperMap GIS as a digital system that can manage and visualize geospatial data for urban planning applications, including its integration with the building information models or BIMs. Actually, I really like the part wherein we integrated BIM with SuperMap. The live demonstration also highlighted how a GIS platform like SuperMap GIS can be a powerful tool for the construction and visualization of an urban digital model, and how such model can facilitate implementation of smart city projects. With this virtual engagement that we had through this webinar, I am hoping that we have gained new knowledge about the use of GIS and other geospatial approaches to land use or urban planning and smart city projects. I am also hoping that the various applications and capabilities of SuperMap GIS that were presented and demonstrated will help our participants decide in using SuperMap GIS in their current or future projects. Thank you once again, and I wish everyone a great and safe day.
Thank you, Engineer Jojin. We are equally thankful for this opportunity to partner with you in this webinar. And thank you so much, everyone. We highly appreciate your attendance today. Feel free to visit the SuperMap website to get more information about the company. We also invite you to follow SuperMap GIS on Facebook, Twitter, and LinkedIn, because we are constantly posting about the latest GIS trends and what SuperMap is currently up to. For the students, SuperMap is offering an open internship program. You might also be interested to become one of our university ambassadors. You will become part of the SuperMap team wherein you will represent your university. More benefits are indicated on our Facebook page, so make sure to like and follow SuperMap Philippines. Again, thank you for attending this webinar, everyone. Don't forget to answer the evaluation form, which you can find in the chat box, so we can bring you a more improved webinar experience. Expect your trial licenses and certificates after output submission in a few days via email. SuperMap will hold more webinars on more topics soon, and we hope to collaborate with more universities in the Philippines.